You may have already noticed some other ways we can simplify logarithms. One of them is, in addition to these properties of logarithms, there's a couple of other ones that we might want to note here. And one of them is the fact that if you've got log base A of A, that one, of course, can always be, if you've got the base A here and then the same number here, that's always going to reduce down. And it's always going to reduce down to be 1, isn't it? Because basically what this is saying is I've got base A and I want it to be A, so logarithm, that means A to what power is A, all right? That's what that means. Well, that's always going to be 1. Now, that may come up, log base 2 of 2 is 1, log base 3. But specifically, one that we'll use quite a lot, probably more next time, but is this one. Isn't that just a special case of that? Because ln of e, the logarithm here is base e. So this is base e to e. So that's 1, okay? So that's the one in particular that is of interest to us. If you've got the ln of e, that's always just 1. All right. Now a couple of other ones. They kind of come from really just the definition of logarithm. And another feature of these being inverse functions, if I've got log base A of A to the B power, that turns out that's always going to be whatever that B power is. And there's several ways to see why that is, but basically what this is saying is if you've got log base A and then this is base A and then you got this B power, what this is basically saying is those two things cancel out. It's kind of a cancellation, and you just get B out of it. Okay? Log base 2 of 2 to the 100th power. The log base 2 and then the base 2 there, those are going to cancel out, so you're just going to get, it's kind of a cancellation property. And again, there's several ways you can see that. You can just go back to the definition. The fact that they're inverse functions, that's really where this comes from. Inverse functions cancel one another out. And you've got log base A, and then you've got A to a power, the exponential function. So those are inverse functions, so they cancel one another out. Now, a related note is, it goes the other way. If I've got A, and then I've got that raised to the log base A of B, very same idea. I've got A to a power, but the power is a logarithm. And the logarithm is logarithm base A. Well, again, because those are inverse functions, and inverse functions cancel one another out, right? If you think about, here's what I mean by that. Square root of x and y equals x squared. Those are inverse functions. They're inverse of one another. Well, what I'm saying there is inverse functions cancel one another out, because if you do the square root of x squared, the square root and the square cancel one another out. You just get x there for positive numbers anyway. But that's what I'm saying. They cancel one another out. The fact that exponentials and logarithms, that's the way we began logarithms, saying logarithms are inverse of the exponential function. These are going to cancel one another out. So I've got A to a power, but the power is log base. Those are going to cancel one another out. And so you just get B there. Does essentially what we're saying is, yeah, if you've got a to the log base a, those cancel one another out. They're inverse functions. So if you've got 8 to the log base 8 of 50, the 8 to the log base 8 cancels one another out. That's just 50. Okay? And that is a property we'll use later on. So just a couple more on those. Again, just a couple of them. And these you can get a couple of ways, but what we talked about. But just by using these two properties, doesn't that cancel out? And that's also 50? Because this is base E, and then you got e to the 50th, so those are going to cancel out and just give you 50 there. So Ln again is base E, you got E, so those are going to cancel one out. Get 50. And then again, just recognizing what the base of logarithms, what base logarithm is this? 10. That's base 10. Yeah, if it's log and there's no base written, that's base 10. So you got 10 to the log base 10. So that's an application of this property here. What is this? Just 78, yeah, because those are going to cancel out. So it has to match. Like if I try to do this with 2 log base 3 of 55, those don't cancel out, right? Because they're not the same base. It only works if they have the same base, okay? These don't cancel. There's no simplifying that. It has to be the same base. And then one other one, and that is, let's just use the 2 again. 2 to the 3 log base 2 of 5. Now be careful. All right, so for this property to work out, you don't need a number in front there. It's kind of like some of the ones before we could use this, we had to use this, right? Same idea here. Before I can use this on that one, what do I have to do? I need to move that 3 inside there. I need to move the 3 inside because to use this property, you can't have a number. There's not a number out front here. So to use this property, there can't be a number here. So one thing we can do on this is use property 3 of our logarithms and bring this inside. Now where does it go? It's a power. So it'd be 2 to the log base 2 of 5 cubed. Right? Now we can cancel. Use this cancellation thing. 2 log base 2, so it's just 5 cubed, which is 125. Okay? Any question or concern there?